So we'll see an example. The question is, tap A can fill a tank in 36 minutes and tap B can empty the tank in 45 minutes. If both the taps are open together, what will be the time taken to fill the tank? So in this question, tap A fills the tank and tap B empties the tank. So what is the filling time? Filling time is 36 minutes. And what is the emptying time? Emptying time is 45 minutes. So which is high? Emptying time is high. So it means that emptying efficiency is less. Filling efficiency is more. So then what will be the overall effect? The tank will be filled. So here the question is, what time will be taken to fill the tank? So no need to worry whether it is filling or emptying. So here it will be filling only, and the question also they have mentioned it. So no need to worry about that. So just write the difference in the denominator and get the time taken by both the taps to fill the tank. So we'll see the working. So here pipe A fills in. So taps and pipes both means the same. So in this question they have given tap, and if it is given as pipes also the same working. So for a working purpose, so we take both as same. Taps and pipes both means the same, and cistern is the one which holds the water. So they may say taps and cistern or pipes and cistern also for this topic. So here it's given as tap A fills in 36 minutes. And tap B empties in 45 minutes. So now emptying time is more, so efficiency is less, overall effect will be filling effect. And in the question they have clearly mentioned time taken to fill. So no need to worry taking emptying minus filling and all, just write the difference in the denominator. So now we can use this AB by here B minus A, emptying minus filling for time taken by the taps to fill or empty. Here it will be filled. So now we can use for A 36 and for B 45 and work out. So but instead of taking these values as such, we can find the ratios where we can simplify the workings first itself. So here time taken is 36 and 45. So now how we can simplify this? So what is the common factor you see here? So both factors are both are multiples of 9. So common factor is 9. So what is the ratio? It is 4 and 5. Now with the ratios itself you can work out this. So product by emptying minus filling. So emptying time is 45 plus 5 minus 4, or just you can write the difference 1. And into the common factor once. So now what will be the time taken here? So when both the taps are open, the tank will be filled in. So 5 minus 4 is a positive value. So the tank will be filled. So 4 into 5, 20 into 9, it is 180 minutes. So time taken by both the taps, here filling effect, it takes 180 minutes for these taps to fill the tank when opened together. So here we have got given in minutes, so we get the answer in minutes, 180 minutes. So when you are checking the option, see whether you have this 180 minutes there, or what is the equivalent value for 180 minutes. So 60 minutes 1 hour, so they may give 3 hours also. Here dividing by 60, so this is equivalent to 3 hours. So check if you have this value, or else the equivalent for this 180 minutes is hours, so 3 hours will be the answer. So here filling efficiency is more, so final effect will be filling. So for filling and emptying product, just write the difference because they have mentioned as filling. So difference into the common factor 1. So easily you can arrive at the answer. So answer is 180 minutes or 3 hours. We'll see the next example. So we'll see the next example. So the question is, a tap can empty a tank in 1 hour. A second tap can empty it in 30 minutes. If both taps are open simultaneously, how much time is needed to empty the tank? So this question was asked in SSC, CGL Tier 1 2000. And now, here in this tap A, so one tap empties the tank in 1 hour, The second tap empties the tank in 30 minutes. So both the taps are emptying. So here you have to note the units also. The tap A empties in 1 hour. So second it is given in minutes. So what will be time taken by first tap to empty the tank? 60 minutes. And what is time taken by second tap to empty the tank? It is 30 minutes. So earlier example we saw one tap filled and the other emptied. Here both the taps are emptying. So when both taps are emptying is given, so we can take time taken by both taps are filling itself. So we'll see the working here. So when both taps are filling, so we used AB by A plus B. So A is time taken by A to fill the tank, B is time taken by B to fill the tank. So time taken together, we used AB by A plus B. Suppose one filling, one emptying. So we use AB by difference in emptying minus filling. Suppose if B is emptying, so we took emptying minus filling. So in this question, both times are given as emptying. So both emptying, so it is equivalent to time taken by both the taps filling the tank. So you can use the same formula AB by A plus B, and both are emptying time. The final answer which you get will be the time taken by both the taps to empty the tank. So when they give both emptying, so it will be like so when both taps are filling, so time taken will be when both filling will be equal to when both the taps are emptying a full tank. So remember that when both taps are filling, we will use AB by A plus B. That will be time taken together for the taps to fill. So if both are given as emptying, we can use the same AB by A plus B, which will be time taken by the taps to empty the whole tank. So here we have got both filling, both emptying. So overall effect we can use AB by A plus B, and that will be time taken by both the taps to empty the tank. So time taken for both filling is also equal to time taken by both the taps when they are filling, when they are emptying. So the first tap empties in how many hours? 1 hour. The second tap empties in how many hours? So it is given as minutes, 30 minutes. So we'll have this also as minutes, 60 minutes. So here the first tap empties in 60 minutes, second tap empties in 30 minutes. So for both open together, time taken to empty, we can use the same which we used for both filling. So remember, both filling time and both taps emptying time will be same. So you can use the same AB by A plus B. So now we can use for A 60 and for B 30 and find time taken for emptying. Now instead of taking with 60 and 30, so we will get the ratio. So that is a common factor. So it is in the ratio 2:1. So common factor we have taken out is 30. Now we can work this AB by A plus B for this ratios itself. So when both the taps are open, so time taken for them to empty is 2 into 1, I2 plus 1 into 30. Now what is time taken? So 60 by 3 or 20 minutes. When both the taps are open, time taken by them to empty the tank, we have used that same formula which we use for both filling, that is AB by A plus B. We have got 20 minutes as the answer. So I will give you another clue to work out the questions where the data of this type. So can you see any relation between this data? So one takes 60 minutes, the other takes 30 minutes. So one is double of the other. means the ratio is 1 is to 2 or 2 is to 1. So the easy method to work out the answer is, so whenever the ratio is 1 is to 2, so whatever the higher time is, answer will be 1/3 of the higher data. So this is for both filling. So when the taps both fill, so now when they are in the ratio 1 is to 2, that is double the value, answer will be 1/3 of the higher value. Say suppose if it is 10 and 30. (15 and 30). So when the timings are double, 15 and 30, so what will be time taken for them to both to fill? Or if both are emptying, what will be time taken for both the taps to empty? So it is in the ratio 1 is to 2. So you see what is the higher value. Divide by 3, you get 10. So 10 minutes will be the answer. 1/3 of the higher value. Because when they are in the ratio 1 is to 2, so here 2 into 1, we divide by 3. So into the common factor, we get the higher value by 3. So it is 1/3 of the higher value. Suppose if it is in the ratio 1 is to 2, so mostly they give in this values, in this data, so just take 1/3 of the value for both filling. So if it is one filling and the other emptying, so when it is in the ratio 1 is to 2, say we will take for the same data 60 and 30, the higher value will be the answer. So because in the denominator, filling will take 2 plus 1. So when it is 1 filling, 1 emptying, we will take the difference. So what is difference for 1 is to 2? It is 1. So whatever the value is, it will be the answer. Higher value will be the answer. Suppose you have time taken 45 and 90. So one filling, the other emptying. So it is in the ratio 1 is to 2. What will be the answer for time filling or emptying according to the data? The higher value will be the answer. So understand? So whenever you see the data 1 is to 2 ratio, so you can take that time filling will be higher value by 3. When one filling, the other emptying, you can take the higher value itself as the answer. The same way you can try for when it is 1 is to 3 also. So when it is 1 is to 3, what will be the value? The higher value, whatever the higher value, it will be 3/4. So because product is 3, sum is 4. So here product is 2 and sum is 3, so that LCM will multiply, so it will be 1/3, or it will be 3/4 of the value. So you can try for other ratios also. And for this, as you have the data as double 30, 60, so using these ratios, we have got A and B empties the tank in 20 minutes. So here remember the clue that when both filling time and both emptying time will be same. When both the taps are filling or both the taps are emptying. We'll see another example. So the question is, 2 pipes can fill a cistern in 3 hours and 4 hours respectively, and a waste pipe can empty it in 2 hours. If all the 3 pipes are kept open, so then what will be the time taken for the cistern to be filled? So this question was asked for the SSC CGL Tier 1 exam 2004. So in this you have more than 2 taps. So we have 3 taps here. So 2 taps, 2 pipes fill in 3 hours and 4 hours respectively. And the third pipe empties it in 2 hours. So what is time taken by the pipes to fill the cistern? So more than 2 taps. So the better method is for easy working. So we can use the LCM method which we saw earlier. So we'll see the working now. So there are 3 pipes. So pipe 1, 2 and 3. So what is time taken by the first pipe to fill the cistern? So it fills in 3 hours. And the second pipe fills the cistern in 4 hours. And the third pipe, the waste pipe, empties the cistern in 2 hours. So as it is emptying, so we can make it as -2, so that we not forget as minus here, or else we'll add everything. So here first two pipes fills in 3 hours and 4 hours. The third pipe empties in 2 hours. So I have written the timings here. So LCM concept is take LCM for all this time taken. So for 3, 4 and 2, what will be the LCM? So it is 12. So we'll assume that there is a tank which can hold 12 liters. So if there is a tank of capacity 12 liters, the first pipe, if it is filling in 3 hours, so in 1 hour, so how much water the first pipe can pour? Divide 12 by 3, it is 4 liters. And the second pipe in 1 hour, so it can fill it in 4 hours, so dividing 12 by 4, it pours 3 liters. And the third pipe empties the cistern in how many hours? So in 2 hours it is emptying. So if this third pipe empties a 12 liters tank in 2 hours, so in 1 hour, how many liters it can empty? So 12 divided by 2, it is 6 liters it empties. So as it is emptying, we'll take minus. So effectively, how much water will be there in the cistern when all these 3 taps are open? So the first pipe, the second and the third. So when all the pipes are open in 1 hour, so 4 plus 3, 7 minus 6, it is 1. So there will be only 1 liter of water in the cistern when all the 3 pipes are open. So if all the 3 pipes can pour only 1 liter per hour, so what will be time taken by these taps, these pipes to fill this cistern? So we have assumed as 12 liters. So to fill 12 liters, they will take 12 hours. So for in 1 hour, 1 liter to fill 12 liters. So all the 3 pipes need 12 hours. So here more than 2 taps. So we took LCM for all this time taken 3, 4 and 2. That is 12. And we have converted the time as work. So first pipe pours 4 liters. Second pipe 3 liters. Third pipe empties 6 liters. Effectively we have only 1 liter in 1 hour when all the 3 pipes are open. So if they can pour only 1 liter per hour to fill 12 liters, what will be time taken? 12 hours. So we'll see the next concept.